Hey everyone. So we're going to be going over 3.1 functions today. We're going to address domain and range and everything else that comes along in this chapter. So starting off here with functions, they mention the domain. So just a refresher, domain represents x values of a function. So the domain of a function is its x values. And we can represent that as an interval, or if it's just points, we represent it as just x values, so integers. And then the range is going to represent the y values of a function. So when we see this problem, it says determine the domain of the variable x in the given expression, and it has x subtract 1 over x plus 7. Our options right here, we have the domain is x when x cannot equal a certain value, and then the domain is a set of all real numbers. The only time we're going to have an x cannot equal something is if there's a certain value that's going to make that function undefined or not real. And this is one of those cases where we have a number that's going to make this undefined, because we know that if we have a 0 on the bottom of a fraction, it's undefined because you cannot divide by nothing. So whenever 0 is on the bottom of a fraction, it is undefined. So that would make this graph not possible if it was undefined at that certain point. So how we find that is we set it up to be x plus 7 equals 0, and then solve for x, subtract 7. So x equals negative 7 here. And this is the value that x cannot equal. Because if x equals negative 7 here, we'd have negative 7 plus 7, which is 0 on the bottom. If 0 is on the bottom of a fraction, it's undefined. So we put this negative 7 into the domain is x when x cannot equal negative 7. Because that is the only value on that graph that's going to make it undefined. So we cannot use that value. Let's continue. State the domain and range for the following relation. Determine whether the relation represents a function. So also, domain is x. We also call x the input. I'm trying to decide where to put that. Which would make range the output. So right here, our sun is going to be our input, our x value, our domain. And the mother is going to be the range on this one. And the reason that this is the domain is because it's this to that. So that's what we need to know. Choose the correct answer below. We have options. So our domain is going to be Abby, Benny, Gil, Hoda, and Megan? Okay, so Hazel, Alexa, Rydell, no, those are mothers. No, no, yes. These two are reverses. The other two don't even list the full options. They're not going to magically lose part of that option, so. And then they ask, is this a function? So the rules on functions is that you can only have one domain value per range value. If it's a 1-to-1, you can only have one x and one y, no repeating. So our x values can't repeat. So if we had like right here from Hoda, instead of having like, how do I want to say this? If I had like another arrow from Gail going to that one, that would make it not a function. So if there was one x value that had two arrows coming from it, it would not be a function. Since this one shares here, that's okay though, because this isn't a 1-to-1 function. If it's 1-to-1, everyone has to go to just one. These two going there though, this is still a function. It's if I had one of these, I had two arrows coming from it. I think I'm beating a dead horse on that one. Yes, because each element in the first set corresponds to exactly one element in the second set. Yes, because each element in the second set corresponds to exactly one element in the first set. Yes, because each element in the first set corresponds to exactly one element in the second set. Okay, get rid of this. So state the domain and range of the following relation, then determine whether the input represents a function. So remember, for it to be a domain, no repeated x values. I'm going to write that right here across the top. Functions do not have repeated x values. It's a lot more. Repeated x values. If there's two x's that are the same, it is not a function. So our domain here is just our x values, so 6, -1, 9, and 6. I was trying to determine if they want us to repeat the 6 because there's two 6's. I don't think so, but I'll do it just in case. So since they have the braces on here, you do not need to put parentheses or anything. We're just listing our x values. So 6, -1, 9. And this is what I don't know if they want, that extra 6 on here because it's repeated, but we'll check it. Okay. So do not repeat the value on it. So since there was two 6's, you only can type one of them in. Right. This one, they want that range, so do not repeat. I was like, I don't think it says that anywhere. I don't think I overlooked it. But remember, don't repeat them. So since this is 7 and 7 here, we just need 1 7, comma, 10, comma, 14. Don't forget your commas. But since this graph repeated that 6, and functions do not have repeated x values, this is not a function, so it's not C or D. Now then we have to read this. This relation is not a function because there are ordered pairs with 7 as the second element in different first elements. That is not true because we care about the first element. Our x value is what determines if it's a function or not. So the relation is not a function because there are ordered pairs with 6 as the first element and different second elements. If it had the same second element, it would be the same point. So that's why that's wrote like that. Okay. The domain of the relation is, so we're going to write all of our x values. So we have -3, -2, -1, and 0. Since none of those repeated that first value, I know that this is a function. Okay, our y values are all 1. So I'm just going to put 1, 1 in there. But since the x values determine if this is a function, this is a function still. So not a function, not a function. So we're looking at B and D. The relation is a function because there are no ordered pairs with the same first element and different second elements. And this one says the relation is a function because there are no ordered pairs with the same second element. They all have the same second element and different first elements. Okay, let me erase this right here so we can see what we got. Determine whether the equation defines y as a function of x. So, what's the best way to explain this simply? Y equals 2 over x. If I can write an equation, y equals, it's a function, because there's not going to be that repeated x value. This is a reciprocal function. In fact, it's stretched by 2. We're going to get into that stuff later on. I'm trying to think the best way to, if you can write it y equals, it's a function. Like, it can't be y squared, it can't be y cubed. Like, a circle is not a function because it has y squared. We just did circles, so I feel like I can say that. This one right here, determine whether the equation defines y as a function of x. Since y is squared, if I did the square root of this, I'd have, I wouldn't have my positive and negative here like I need to. Since y squared, it's not a function. Oh man. I know there has to be a better way for me to explain that to y'all. If it's just y equals, it's a function, but if it's y squared or whatever, and I can show you the graph, maybe that'll help make this make more sense. Let me pull that up. Because I don't like how that comes across when I'm explaining it. Let me pull up Desmos. And we'll bring this over here. Okay, and get this, and then, here, we'll go here first. So let's get our graphing calculator up here. I think that's the one we did last time. Okay, so we have y equals 2 over x. This one is a function. I can zoom out because we're not looking at specifics. It gets infinitely closer, but it never repeats because it'll get closer and closer and closer forever. But none of these are the same x value because it's just very small increments. Okay. Then compared to this one, where we have, I'll type it exactly how they have it, x plus 3 equals y squared. Now let me zoom out, and we're looking at the blue graph here, where this graph right here is not a function because they have a vertical line test that if I was to draw a vertical line, oh, can I write on this? I would cross this twice. So the blue graph, I crossed it twice, so that means there's that repeated x value, and functions do not have repeated x values, where we cross the green graph just once. If you need to check that, you can go to this Desmos graphing, but if it can be y equals, it's a function, but if y squared or absolute value of y, you're looking into other things. Okay, I'm not going to get rid of this in case I need it later to help. So let's go here. Find the domain of the function f of x equals negative 3x plus 7. Real quick, because I don't think we've looked at this before. This right here, this f of x, that's how you say it. This is function notation. This f of x is the same as a y, like it's an equation, but we write it f of x so that it's this function that represents all of the values you can put in it. It represents all of the input, all the x values I put into this graph would get that output value, that y value. So we use this function to represent the entire line, the entire graph, where y equals it is just an equation. For all shapes and purposes doing this, these are related to each other. So if we were solving for y, we would plug in x, and whatever f of x equals would be that y value, that output value. Okay, so our domain on this graph, since this is a linear graph, get rid of these. It's a linear graph, and I think I'll type in f of x equals negative 3x plus. So looking at this graph, do you see any holes or asymptotes, any of that? It's just a line. So on this one, there's nothing that makes it undefined. Like our very first problem we did over here, if they ask for the domain of this one, there's going to be a hole in this graph at negative 7. There's going to be a hole in this graph at 0. There's going to be an asymptote there at 0. And this one's not a function. So here though, since it's a linear equation, it is a line. Our domain is all real numbers, but they want it in interval notation. So our interval notation for all real numbers is negative infinity to infinity. I'm gonna get rid of input, output too, because all real numbers. There's nothing that's gonna make this undefined or not real. And I keep saying not real because if we had a negative under a square root, that would be not real. I think there's an example like that. So since this is a linear equation, it is a line, there's nothing that makes this undefined or not true. This is our answer because they want interval notation, negative infinity to infinity. Remember, when you do interval notation, you cannot put a bracket with an infinity because we cannot equal infinity. Okay, what's next? This one. So here, 3x squared plus 7, we need to determine if that was set to 0, is there a value that's going to make this undefined? So we're going to take this denominator, because if the bottom of a fraction is 0, it's undefined, it's not true, and it will not work. So let's go ahead and solve this. So we're going to subtract our 7. So I'd have 3x squared equals negative 7, divide by 3. And I would get x squared equals negative 7 over 3. Opposite of a square is a square root. So I have x equals the square root of negative 7 over 3. Well, that's not real. Because we can't have the square root of a negative, remember. Let's go ahead and pull up our graph and double check. So right here we're going to have f of x equals x divided by 3x squared plus 7. Not equals 7 plus 7. Okay, now let's zoom in on this graph because I have it way zoomed out. So where I think there is a hole, seven over 3 would be a little over 2. It would be like 2.33. And since there's not a thing as that square root of a negative, I think we're gonna be okay. Double check over here. I thought it used to mark. But let's see. Yeah. So since this one set equal to 0, I think it's negative infinity to infinity. We're gonna check it. I don't know if I remember telling y'all at the beginning of this semester that I'd redid this assignment so that I could update our course. So I haven't worked out all these problems before because some of them are different and I just had to make it real quick. So we have x squared subtract 100 equals 0 because we're determining if the bottom of this is 0, what values would make it not true. What squared subtract 100 is 0. So this is the difference of two squares. If I move my 100 over and we take our square root. Remember when you do the square root method, you have a positive and negative. So the two values that cannot be in this is positive and negative 10. Oh, yuck. Okay. They want this in interval notation. We can't have a positive or negative 10. So when we go to write this in interval notation, we're going to have negative infinity to negative 10 unioned with negative 10 to 10 unioned with 10 to infinity because they wanted interval notation. If it was like earlier where it just had plug in the number, you could do the cannot equal this. But here we go. And you write the -10 and the 10 on this, you just can't use brackets with them because that would mean it's equal to, and that's when it's undefined, so we can't do those. Here we go. Negative infinity to -10. Remember to use this union sign on your keyboard right here. And then parenthesis -10, +10. Union again, 10 to infinity. And don't put commas by your unions, but be sure you use them. You can't use a U on your keyboard, it does not like that. At least it didn't in the past. Okay. This part right here is where I was saying it can't be a value that makes it undefined or not real. So when we work out this one, we have the square root 2x subtract 4. And I don't need the square root for this part. I just need 2x subtract 4 has to be greater than or equal to 0 because that's what's going to be under this. If I have a 0 under a square root, it's 0. If I have a negative under a square root, like if we didn't set up this parameter that it's greater than or equal to 0, it could be that imaginary I unreal, because if we have a negative under there, it's going to be not real. And then we'll solve this with this stipulation that it's greater than or equal to 0. So 2x is greater than or equal to 4 divided by our 2. So x is greater than or equal to 2. Right. And this right here is where all of our interval notation stuff we've done previously comes into play. This one is equal to. If it's equal to, it's a bracket. And it's everything that's greater than 2, so it's going to be bracket 2 to infinity. And the reason we did an inequality on this one is because it has to be greater than 0, or you're going to end up with an imaginary number. And they want real values. Remember, infinities have to have parentheses because you cannot equal an infinity. Okay. If f of x equals 4x cubed plus ax squared plus 9x minus 5, and f of 2 equals 1, what is the value of a? Okay. Math time. Let me write my equation here. We're going to solve for this a right here. They gave us our x and our y value. I'm going to get rid of this because they're not asking about domain and range anymore. Minus 5. And they tell us right here, f of 2 equals 1. This f of x equals y. So our y value is 1 and our x value is 2. So right here, we're going to have 1 equals 4 times 2 cubed plus a times 2 squared plus 9 times 2 subtract 5. So I'm going to go ahead and do my exponents and multiplication on this side. So I'm going to have 1 equals 4 times 8. I should have went ahead and done that. Oh well. 2 squared is 4. I'm going to put the 4 in front because it bothers me if it's not. 9 times 2 is 18. Subtract 5. 4 times 8 is 32. Plus 4a. 18 subtract 5 is 13, right? 14, 15, 16, 17, 18. Okay, we're going to do 32 plus 13. So 1 equals 4a plus 45. I'm going to subtract 45 from 1. I'm going to go, where do I want to do this? This is backwards, sorry y'all. So 1 equals 4 a plus 45. No, I'm gonna continue. So I'm gonna subtract 45, because we're solving for a. So I'm gonna have negative 44 equals 4a, divide by my 4. So we have negative 11 equals a. And that's what they want. So the big thing on this is setting it up. Remember that the f of x equals y. Y is the same as f of x, so we substitute 1 for the f of x, and then we put the 2 that represents the x into all of this, and then just algebra it out until you solve for a. Okay, I think the next one's probably one like this. It's different, but similar. Because we're still solving for a. Alright, we have T of P equals 3P minus 6 and P minus A. T of P. I hate when they change it up like that and just use crazy variables. It doesn't change how you do the math. I think it just makes it a little more confusing. So they give us T of 0 equals 2. And since we have T and P, it's going to be T of P. I don't know what they're calling the other variable. Oh well. So, on this one, this 2 is going to go here. And then we're going to have our p value is this 0 right here. So I'm going to have 3 times 0, subtract 6, over 0, subtract a. 0 times anything is 0, so let's just rewrite this real quick. 2 equals negative 6 over negative a. Negative divided by a negative is positive, so we have 2 equals 6 over a. Now I need to solve this for a, so I'm going to multiply by a on both sides. So now I have 2a equals 6, and then we divide by our 2. So a equals 3. Didn't the last one equal 3 too? No, it was negative 11. Okay. That was your crash course reminder on functions. Let me know if you have questions. I'll address them in the new videos. Y'all are helping me significantly by improving. So just let me know how I can improve. Thanks.